Hello everyone and welcome to a new video from Machine Learning with Hamza. So in today's video we're gonna try something different and we're gonna talk about something really cool and really interesting in the AI art field. So in today's video we're gonna see how we can use Stable Diffusion on our local machine and also how we can fine-tune it either on our local machine using Textual Inversion in case of course we have somewhat of a good graphic card, or using any cloud service that grant us the access to using GPUs, powerful GPUs that has more than 16 gigs of VRAM. So in today's video we're going to use the free version of Google Colab that you can also use for free and fine-tune your Stable Diffusion on your own subject or your own style using a notebook called DreamBooth. And we're going to go through all of that in today's video. So hopefully you find it interesting and that you have fun with it. And if you do, don't forget to subscribe to stay tuned for more videos. So without further ado, let's dive deep into Stable Diffusion. So to start, we're going to head over to GitHub. We're going to go to the Stable Diffusion Web UI repository by Automatic1111. So we're going to clone this repository, which allow us to use Stable Diffusion through a Web UI locally, of course, on our machines. And we're going to go, first of all, over the installation and running instructions. For automatic installation on Windows, we need, of course, Python, we need the Git, and then we're gonna run the command git clone to clone this repository. Of course, you can always download it through this button, download zip, but using the git and git clone command is much more efficient and much more easier. And you can then pull the repository whenever there is a new update. So by running this git clone command, you will end up having a folder like this one called Stable Diffusion Web UI, which contains all the necessary files for your web UI to run, and of course to run the Stable Diffusion model. So this web UI was creating using Radio, which is an open source library to create web apps for machine learning models. Then of course the next step is going to be getting the model file, which can be done through this link dependencies. And when you click, you'll end up on this page. You go to official download. And then on the official download page, you click on this CKPT file to download the weights. Here we have the model version 1-4. But of course, if you're watching this video, maybe in 2, 3 or 4 months, you'll find later versions that you can use. After downloading this file, you can head over to the models folder in the Stable Diffusion Web UI, and then to Stable Diffusion folder, and you place the model file over there so that the web UI can access it, and of course then you can use it on the user interface. And this is the final step of the installation. So now you have installed the web UI. All you need to do right now is to run this web UI user batch file, and by running it, it's going to take some time to install all the required dependencies and to launch the backend server for the web UI. It's going to take around maybe 30 or more minutes, and I already ran it, so it's not going to take as much for me this time. It's only going to import the required dependencies, set up the backend for the web user interface, and we're going to launch it through the URL that's going to provide in a few seconds. And here it is. So running on local URL, we're going to head over to this URL, just copy it, and then we're going to go over here and paste it. And voila, so we have the user interface over here. So we have multiple tabs. We're going to go through the tabs, but we're going to mainly focus on text to image, image to image, and textual inversion, and some of the settings over here. So let's start first of all with the text to image. So text to image is the first tab we have, and it is the basic application of the Stable Diffusion model. It takes the text that we input and tries to create an image that can be described by that text, and outputs it over here in the this area. So for example, let's try a cute brown cat. Then we click generate, and for now we leave all the other parameters by default. So here we have a very high definition image of a cat, of a brown cat. We can add, for example, other details. A cute brown cat wearing a hat, and we click generate again. So we have another image of a cat but not wearing a hat. So to get better results, we need to modify these parameters, or of course play more with the prompt. So the prompt has the most weight on the output image. So playing around with the prompt, trying different tags and different kind of tokens can produce very interesting results. So for now, let's leave the prompt as is, and we're gonna see how we can modify these parameters to obtain better results. For example, if we put the sampling steps to, for example, 1, and we generate, let's see the image, it's not even recognizable. That's because the Stable Diffusion starts from an image of noise, and each step it generates a new image and tries to match the described text that we used as input. So using, for example, as we did the first time, 20 sampling steps, it generated a cat. Let's see. So it generated a cat, but it didn't reach the part of wearing a hat. So to do that, we're gonna increase, for example, the steps to 50. Let's check the results. And here again, we have a cat that's not wearing a hat. So we're gonna increase a little bit more, 75. Okay, so now as we can see we have a cat and it is indeed wearing a hat. So using 75 sampling steps we obtained good result. Let's try another image, generate again. Okay, so we have another image of a cat wearing a hat and it looks pretty much realistic. So this is for the sampling steps. As I played around with this parameter, I find that maybe over 80 or 90 sampling steps the image does not change a lot and the quality remains the same. So using maybe 70 or 60 sampling steps would be quite optimized for this method. Of course, here we're using the default settings, which uses Euler A sampling method, but there are many more sampling methods that we can use, and here we can try the LMS, for example. Okay, so this is the result that we obtained using the LMS sampling method, and clearly it's a picture of a cat that's not wearing a hat. So to improve this result for the LMS method, we can, for example, try to add some parentheses over wearing a hat to add more emphasis on this part of the prompt. So by adding, for example, more parentheses, you're basically telling the algorithm to focus more on this part of the prompt. So let's generate again. Okay, so now we have indeed an image of a cat wearing a hat, and it is quite defined, but it is not very much realistic or highly defined as the previous images that we obtained using Euler A. So by playing around and trying this different sampling method, you can find the one that works better with the style that you're looking for and that produces better image that you find more realistic or more in a style that you are aiming for. Of course, you can find some other informations about this sampling method. For example, here we have this image on the stable Diffusion Reddit, which describes or which gives us an idea about the different sampling methods we have. So here we have Euler A, Euler, LMS, PLMS, for example, that we also have on the web UI, Euler A, Euler, LMS, and PLMS. And we can see over different sampling steps the results that can be obtained using the same prompt. So here we can remark that Euler A changes the style and the image itself over the sampling steps. Even when we get closer to 60 sampling steps, the image is still changing. But for the LMS and PLMS, and even for these algorithms, we can see that the image is quite consistent over the sampling steps. And that's why the LMS sampling method is commonly used, as well as the dim and Hoin. So that's what we're going to use for the rest of this tutorial. So we're going to keep the LMS sampling method. We're going to move over to the width and height. So by default it's 512 by 512. So the Stable Diffusion has been trained on 512 by 512 images. Of course, you can augment, for example, the width to 1024. It's gonna be more consuming and it requires more VRAM to run, but we can try it. So as we can see here, we obtained a larger image in a landscape mode of two cats wearing hats, but it takes more time and it is more computationally expensive, so we're gonna keep it at 512 by 512. Okay, so let's keep these three settings, restore faces styling and high-res fix, as they are for now. So for the batch count, so we have here by default batch count 1 and batch size 1, indicates how many batches that we want to produce, and the batch size indicates how many images by batch. So for example, if we produce 3 batches with 2 batch size image, we're gonna have 6 images as total output. Okay, so here's the result. We obtained 6 images. So we have 3 batches, and in each batch we have 2 images. So we have some cool results here, but we also have other bad results, which does not really reflect the prompt that we chose. So we're gonna see how to improve that. So for now, let's keep the batch count at 1 and the batch size at 1. And we're going to reduce the sampling steps to 60 because it takes a lot of time to generate these images. So we're going to move on to the next parameter, which is the classifier free guidance scale. So this scale indicates how much should the algorithm stick to the prompt that we created. So using a CFG scale of 1 would tell the algorithm to create an image from its own imagination, and it will not clearly use the prompt that we chose. So let's try and run it here to see some example. And as we can see here, it followed the prompt quite a lot, but if we run it again, we're gonna see that it produces something totally different. And as we can see here, it produced an image of somewhat a face of a human, or in that style. And of course, if we upscale the CFG to 30, we're telling basically the algorithm to stick firmly to the prompt that we provided. And in most cases, it would produce something not at all recognizable, some sort of noise or things like that. And here we can see it. It is not even recognizable. We can see the outline maybe of the hat here, but it's not at all well defined. So it is better to keep the scale between 7 and 12 is commonly used. So we're gonna keep it at maybe 9 for the moment. So let's generate again. And as we can see here, we have clearly an image of a cat which is wearing a hat. So using this CFG scale, we can tell the algorithm to conform to the prompt that we're using. And we've seen earlier that using these parentheses, we can tell it to focus more on a certain part of the prompt. So now let's see how we can reproduce a certain result. So for this image, we have a certain seed. So if we copy this seed and enter it here, we can generate the same image again and again, The seed is used to assure reproducibility. So using the same prompt and the same seed, we can reproduce the exactly same image. And this is quite powerful because we can then see how we can use it to modify the produced image or to enhance it even more. And we can set the seed to -1 to tell the algorithm that it can choose any seed that it wants, and it will generate basically a random image. If we want to revert back to the seed that we used earlier, we can click on this icon here, or we can copy the seed from here. So let's set it to random seed. So in this last parameter, which is the script, we can see that we have 3 scripts here. We have prompt matrix, prompt from file or text box, and XY plot. So let's check first the prompt matrix. So we can use the prompt matrix to create variation and combination from different prompts. So let's head over to the prompt. Here we can, for example, add a vertical pipe, and we can add a random artist name that is supported and can be used with Stable Diffusion. We can add another pipe and add another artist name, and let's generate. Okay, so now here we have the result of the prompt matrix. So the first prompt without any artist style, we have this image as a result. Using the Harrison Fisher style, we obtained this image, and using Alan Butler style, we obtained this image, and the combination of both artists resulted in this image. Okay, so this is the example for the prompt matrix. Let's now try and use the XY plot. So the XY plot allows us to create a grid of output images using a variation of the parameters of the model. So for example here, in the X value we have sampler, for example. We can change it from this list. But using sampler, we can, for example, say Euler A, Euler LMS, and PLMS, for example. And for the steps, we can try for 10 steps, then for 20, for 30, 40, 50, and 60 steps. Keep -1 for the seed. We don't want randomness, so we don't want to keep -1 for the seeds. Draw legend, of course. We want to draw legend to better understand the result. And let's generate. So what's going to do is to generate an image for each combination of this value between X and Y value. For example, it will create an image for each sampling steps using the Euler A sampling method. Then it will do the same thing for the Euler LMS and PLMS sampling methods. So let's wait for the results. Okay, so here's the results. We have a grid image. On the x-axis we have the sampler method, and on the y-axis we have the sampling steps. And that's how we can use the XY plot. We can try different parameters. We can also try different seeds. We can try different CFG scales. And we can use this script, which is the XY plot, to better understand each parameter and how it works and how it impacts the output image. So this is how we can use the XY plot. So the prompts from file or text box, this allow us to generate multiple images from multiple prompts. So if we have already prepared a text file, or we can use here this text box to create multiple prompts. For example, a cute brown cat. This is the first prompt. So the second prompt will be a game male character, a cyberpunk city. Okay, then after creating the prompts that we're gonna use, we check show text box, and we click, we remove this prompt and click generate. Okay, so we obtained 3 images, one image for each prompt that we created. The first one is the cute, oh, here we typed crown, but we meant brown. So we have a cute cat. We have a game male character. We have a character design here. And then we have a cyberpunk city. So this is how we can use the prompts from file or text box, and this method allows us to create different images for different prompts at the same time. It can be useful for certain applications. So this is all for the scripts that we have. Okay, so that's it for the first tab, which is text to image. We've seen all the parameters. We've seen some examples using the scripts and different prompts. And as I said, the prompts have the highest impact on the produced image. So using cleverly designed prompt will produce better results. And you can check online for ideas how to create and how to choose the prompts. For example, here, this article I find very interesting, and you can read it to learn how to create your prompts, your own prompts, to create unique styles, and also to mimic other styles that are very much known, and to produce quite cool results. So this is it for the text to image. So let's now move on to the image to image. So here we are. We have this tab which contains the text prompt as in text to image, but we have a new input here that we're going to use. So here we have image to image, inpaint and batch image to image. We can put an image here, and the Stable Diffusion model will use it alongside with the text prompt to produce a new image. And down below we have similar parameters that we can play with. We have only one new parameter, which is the denoising strength, which is a similar parameter as the CFG, but for the image input. So it tells the algorithm how much does it need to stick or conform to the input image. If we put it to 0, the same image we give as input will be kept and given as output, so nothing will changes. and if we upscale the denoising strength to 1, we will have a completely new image, and the input image will be disregarded. So we need to keep a value between 0 and 1. If you want to go for more creativity, you can use maybe 0.7. And if you want to keep the main style and main object of the original image that you input, you want to use maybe 0.3 denoising strength, and you can play with it to find the best parameter for your own application. So okay, so let's set the sampling method as we said to LMS. Let's set the denoising strength to 0.3 and the CFG to 7 or maybe to 8. So we have a digital painting of this character holding an axe. We're going to create a text prompt for this image. So we can say a small character holding or wearing a metal hat and holding an axe. And we can check the parameters. We have similar parameters as text to image. We have only one new parameter, which is the denoising strength. So the denoising strength is similar as the CFG scale for the text to image. It tells the algorithm how much should it stick to the input image. If we put it to 0, so basically we're gonna have the same image that we input as an output. And if we set the denoising strength to 1, we're gonna have totally and completely new image. So let's keep this parameter in the middle, for example 4.5, and let's generate. So here we have a new image. We have a different style of the face. Using this method, we can create original character maybe for a game or for an animation using Stable Diffusion. Let's try and run it over a batch of 3 images. So here are the results. We have the first design. You can see clearly that we have a different design of the clothes, these parts of the face, and the axe as well. We have this character and also this one. Okay, so let's say now, for example, we want a small character wearing a wooden hat and holding a long axe. Okay, so here's the result. So we obtained 3 images. It didn't really capture the wooden hat. The same goes for this image, but we can play more with the prompts, as I said, and maybe the parameters here to create and produce better images. What we can do is use this in Paint. For example, when we import the same image here, and we use the brush to paint over this hat. So then we can tell the Stable Diffusion to only change this hat and keep the rest the same. So in Paint Masked, Draw Mask, then we're gonna set the denoising strength to maybe 7 to allow for more creativity on the masked area. We're gonna say in the prompt wooden hat, and when we generate, we can see that all the image is kept the same except the hat. It changed to this painting, but it's not really recognizable, so we need to add more details. Digital painting of a wooden hat, or let's say wooden helmet. Okay, so now we've got a better result. So here we have a better result of a wooden helmet. We can further refine the masked area to remove these parts, and we can use more prompt ticks to obtain better results. So I've created a cheat sheet for the prompts and for the Stable Diffusion as a whole, and you can find it through the link in the description, where you can find the useful information that I find across the web, and I collected to create better prompts and better generated images. So this is it for the image to image. We check the image to image and the inpaint. Basically, the batch image to image, you input a directory filled with certain images, and all of those images will be processed the same way, and using the same prompt we're gonna generate an image or multiple images for each input image. And the application for this batch image to image, which I find most interesting, is to create animation frame by frame, where we take for example a video of a human being, and we get multiple frames from, or multiple keyframes from this video, and then we process these frames using the Stable Diffusion model to add a style or to make it look like an anime, and then we process all those keyframes and we generate an animated video using the output images, and thus we have a different style of animation of the same human being. So this is it for the batch image to image. You have similar, always the same parameters. So for the extras, we're not gonna go through the extras here because those are not within the Stable Diffusion model. These are used, for example, the upscaler to upscale an image resolution using the ESRGAN or other Swin IR, for example. And I forgot to say, in the text to image, we can check this restore faces to restore, for example, sometimes when we generate images, the faces are distorted or something like that. So we click restore faces, and the UI will install the GFP gun to restore and use it to restore the faces automatically. Here we have the PNG info, which only tells you info about a certain PNG file. Okay, so finally we have the textual inversion, which is the way of fine-tuning, or the method of fine-tuning a Stable Diffusion model. So here we have a wiki file which explains from Automatic 1111, which explains what is the textual inversion. So you can then go through it and read it to better understand textual inversion and how to use it. But for now, let's head over to the textual inversion tab. Okay, for this part, we're gonna need a GPU that has more than 12 gigs of VRAM to be able to train or to fine-tune the Stable Diffusion. If you don't have that kind of GPU, you can skip to the last part of this video where I will show you how to train the Stable Diffusion using Google Colab. But if you have a GPU that is capable of fine-tuning Stable Diffusion, you can follow this part. Okay, so for the first parameter we have here, which is the name, here we will choose the name of the embedding that we're gonna use. or we're gonna create. So for example, if you're gonna fine-tune the Stable Diffusion to be able to create image of your own, you can, for example, create here an embedding called, for example, in my case, Real Hamza. So this embedding we're gonna use in the prompt after training the model to create an image of myself. And in the initialization text, here we're gonna use classes or prompts that are understandable by the Stable Diffusion model as initialization for this embedding. So it better be a tag that describes the subject or the style that you're fine-tuning the model on. So here, for example, we can say male person. For the number of vector per token, usually we use low numbers, and between 2 and 8 are most commonly used, and you can try different values and see which one works better in your case. So then we click create. So it creates this Real Hamza PT file, which is in the embeddings folder, and then we're gonna use it here in embedding. So let's select it, Real Hamza. Okay, so now we're gonna pre-process and use and tell the model which images we're gonna use to fine-tune the Stable Diffusion. Okay, so the source directory, we're gonna copy the link to the source directory. So for the training images, here I have 6 different images of myself from different angles with some facial expressions. So the path would be outside of the Stable Diffusion for me in the training images folder. So let's indicate this path, training images folder. This is the source, and let's call the destination directory training images pre-processed. We want to add captions, of course. Let's add here the slash and create and click pre-process. Okay, so now the images are processing finished. So let's head over to Stable Diffusion. We have a new folder called training image pre-processed, and in it we have the same images but in the shape 512 by 512 and with captions. So here we have a man with a beard and a white shirt. He's looking at the camera with a serious look on his face. So each image, it creates its own caption. Let's go back to the UI. Okay, so after pre-processing and creating the training images, we're gonna head over to the last section. We chose the embedding. The learning rate should be kept as it is or even lowered. For example, 0.01 would be a good choice to start with. Okay, so the dataset directory, I'm gonna copy the destination directory and paste it here. The log directory, you can keep it as it is, and the prompt template file. If you're gonna fine-tune this Stable Diffusion for a subject, for example, as in our case here, we want the Stable Diffusion to be able to recognize the character Real Hamza. So that's why we need to change style to subject. But if you're training the Stable Diffusion to be able to recognize a certain style of painting or any kind of style. So you want to keep here this tag as a style. So if you have very powerful machine, you can keep the max steps to 100,000, but say now in our case we just want a small number of steps. You can lower this to keep more checkpoints of the training. And the last thing, we click train and we wait for the model to train. It's gonna take a while, maybe multiple hours, so you can leave it and come back later. Okay, so in my case I only have now GPU with 6 gigs of RAM. As you can see here, the VRAM 6000 megabytes, so it won't be able to run textual inversion locally. But if you have at least 12 gigs of RAM, you can click train and it will start training, and then you can come back after some hours and use the model. Okay, so to use the model, basically what you have to do is you need to go to the settings and you need to go down to Stable Diffusion, and in the Stable Diffusion checkpoint you will need to select the checkpoint that you're satisfied with from the trained checkpoints that you got. So you only need to select the checkpoint, and then you can click apply settings and return to text to image or image to image, and then generate using your own Stable Diffusion fine-tuned model. So that's it for the textual inversion or fine-tuning locally. We're gonna head over to Google Colab. You can find the link in the description to fine-tune and to train Stable Diffusion on Google Colab. So here we are on this DreamBooth Stable Diffusion notebook. So the first cell, check for the type of GPU and VRAM available. Okay, so now we install the needed requirements. Okay, after installing the requirements needed, we head over to the next cell. We're going to need to log into Hugging Face, which provides the weights for the Stable Diffusion model. So we click this link, model card, this Stable Diffusion V14. If it's your first time on this page, you're going to have to accept the terms of service that will appear here, and then you're going to create an account. You're going to go to settings and access token and create new token. Call it, for example, Stable Diffusion DreamBooth, and set the role to write and generate the token. So here, click here to copy this token. We're going to use it in this notebook. So when we run this cell, we obtain this output where we need to put our token and click login. And if you've done the steps correctly, you will have a successful login. So then we move to the next cell where we install Xformers. So then now we have the settings and run. We have here the model name. Make sure that the model name here is the same as the model name that's been showing in this page, Stable Diffusion V14. So here we have the same thing. If you're watching this video maybe months later, you need to update this version, or check the new version of this notebook. Okay, so then we have here the instance director. We need to provide the director containing the training image. We need to provide the class name and either to save it to the G drive or not. And of course, the output directory that we're gonna create to put the stable diffusion weights in. To do that, first of all, we need to get our training images. And we can do that simply by going to Files and here. So this directory is called Content. We need to create new folder. We call it Data. So in this folder, we need to drag and drop our images, our training images. So here we go here and we upload them to Data. So the file that we upload this way are going to be deleted once we either delete the runtime or refresh this page. It's better to connect or mount our Google Drive and then get the directory path from the Google Drive. But this is the faster way, so we're going to do that for this tutorial. Okay, now we have all the images here in the data folder. So we need to remove this SKS. And then we need to choose a class name for this subject. So here we have images of a person, or a guy, or a male, or anything you want, a man. So you can choose either one of those. So we're going to choose a person. Of course, don't forget to check this to save the weights so that we can download them and use them locally afterwards. And finally, we want the output directory to be stable diffusion weights / for example, here we have real Hamza. Okay, so now we can run this cell. We want to connect our Google Drive so that we save our weights or save the weights that we train. We connect to this account. Okay, now we have we can click refresh and we have the drive here, my drive. You can find all the file from your own Google Drive. Of course, now we have all the settings set up and everything looks fine. So we move to the start training. Okay, so we need to change some parameters here. The instance prompt is the prompt that we're going to use to generate an image of the subject that we're training the model on. So here, for example, instead of this prompt, we're going to use real Hamza as a prompt, and for the class we chose person. So this is the class. So next, for example, in the web UI, to generate an image of Hamza, we need to use real Hamza space person. So this is the formula, or this is the prompt that we need to use to generate or to indicate that we want to generate an image of Hamza. And we're going to see an example of that later on. So we keep the seed as it is. The resolution is 512. Then the batch size is 1. All the settings here looks fine. Except here we want maybe the max training steps to be a little bit less than 1000, maybe 900. Okay, so we don't want to train for more than 1,000 steps because the model will overfit and it will produce poor results for other classes than the class we're training on, and it's gonna really damage the performance. So we keep it for 800 or between 800 and 1000, and we can try different training steps and see what works best for you. So of course, then after we set this up, we run this cell. The training will take a little bit less than an hour, maybe. So we're gonna skip this part and let's skip to the end of the training process. So here the 900 steps of training are finished, so we can move on to converting the weights to CKPT so that we can use them on web UIs. To do that, we first need to download the script that we're going to use to convert the weights. Then we need to run the following cell to convert. If you want to save space, you can check this box to save the model using half precision. So we don't need that here. We have a lot of space on our Google Drive. So we simply need to run this script. It's only going to take a few minutes and we're gonna see the result. Okay, so the conversion has ended, and we can find the weight under my drive, under stable diffusion weights, then real Hamza, and here we can find the model CKPT file. So to download the model, all you need to do is to click download. Here, as we can see here, the model takes 3.9 gigs of memory. I already downloaded the model on my local machine, so I don't need to do that again. Next on this notebook, we have the inference section where you can use the trained or the fine-tuned model to create images. For example, if we run here this cell and this cell to create a random seed, and for example here we create a photo of real Hamza person. As we said, we need to use both the embedding we chose and the class photo of real Hamza digital painting. We don't need a negative prompt. A number of samples, we only need one. Guidance scale, maybe let it at 7. Inference steps 50. Okay, and we run. Hopefully we get a picture that looks like me. And there it is. So it definitely have the same aspect as my own looking, with some digital art style. Of course, you can play with the settings to make it in other styles. Then here we have a grade UI which can be used on this notebook. So if you run this cell, it's going to create a UI here. And here we have the public URL. You can click on it and it's going to take you over to the UI. And here it is. You can enter the prompt, modify some parameters, and you're gonna have the output image here. It's a basic UI only for inference, nothing much. It's similar to the text to image tab in the automatic 1111 UI, as we have here the text to image with less parameters, of course. so we don't want to use this for now. Let's head over here. We can stop this. Okay, so here we have it. We can use it even here. Here it's optional to delete the diffuser weights and only keep the CKPT file. If you want to fine-tune or retrain again to get better results, you may want to use this option to free up some space from the drive. But that's all for the DreamBooth Stable Diffusion or the fine-tuning using DreamBooth on this notebook. And hopefully you followed me and find it easy to follow. So using the downloaded model or the trained model, as I said, you can find it here, or you can find it following this. After converting the weights, it says that you can find the CKPT saved at, and here you have the path. You can follow the path here to find your own model. Okay, so after downloading the model, you will go to, for example, here, this is my own model. I will copy it, go to the Stable Diffusion directory, go to Models, then Stable Diffusion, and here I will paste it, and there it is. So we have it here, and any other Stable Diffusion model that you want to use or any other checkpoint, you can put it here. Then after that you head over to the UI, go to the settings, and down under this section Stable Diffusion checkpoint, you select the checkpoint or the model that you want to use, and don't forget to click Apply Settings. So we're going to use the same prompt that we used on the DreamBooth notebook. And here it is, photo of real Hamza person digital painting. I'm gonna copy it over here. Actually, I trained I fine-tuned my model using the token or the embedding machine learning with Hamza, and using the class person as well. So this is the prompt that I'm going to use. Here you need to type the correct embedding or tag that you chose, as well as the correct class. You can modify the parameters as you wish here. Maybe do it this way, and finally you click generate. Oh, amazing. So this is the picture that we've got, and as you can see, it is a digital painting of myself. That's so cool. Of course, using different kind of prompts and styles, etc., you can produce better images and better styles, and you can play around with image to image or with the inpaint to create wonderful images. So I hope you find this interesting and that you learned how to use this web UI to produce images and to produce wonderful digital art. You can find some great ideas, for example, on Lexica, where people from around the world share their creation of digital art. You can also search for tags here. For example, we can look for mythical characters, and you can find here a lot of images. And the cool thing that you can find the prompt with the seed and the guidance scale or the CFG. Okay, so that's it for this video. I hope you find it really helpful and you create your own cool arts and you share it with the community. And thank you for watching, and hopefully we'll see you again soon in the next video. And until next time, keep learning.